Archimate is an open and independent modeling language designed explicitly for enterprise architecture. It provides a coherent framework for describing complex systems and their interaction across different layers: business, application, technology, and motivation. One of Archimate's greatest strengths lies in its well-defined relationship types. These relationships capture various forms of structural, behavioral, and strategic interactions, enabling architects to visualize how different elements, like roles, processes, services, and data objects, depend on or flow into each other. By employing the right relationship for each connection, architects can build models that are both detailed and easy to understand. Structural relationships such as composition, aggregation, and assignment clarify links between part, whole, and responsibility. At the same time, behavioral connections like triggering and flow highlight how one activity initiates or passes information to another. Dependency relationships such as the serving and realization model, service-oriented or implementation-based ties, and motivational relationships like influence and association illustrate strategic drivers and their impact. Together, these relationships form a powerful language for conveying the intricacies of an enterprise's operating environment and strategic objectives. We'll cover structural, behavioral, dependency, and motivational strategic relationships. We'll also address common points of confusion and provide examples to clarify how and when each relationship is used. Structural relationships show how elements are composed, aggregated, assigned, or accessed. They represent static or part of connections. Composition definition indicates that an element consists of one or more other elements. The whole owns the parts. Composition example: a business process composed of multiple sub-processes, or an application component consisting of specific modules. Key considerations for composition: strong part-whole relationship. If the whole ceases to exist, typically, the parts do as well. Aggregation definition: a weaker grouping relationship where the grouped elements can exist independently of the group. Aggregation example: a program aggregates multiple projects, or a product aggregates various services. Key considerations for aggregation: ownership is not as strong as with composition. The parts can exist independently. Assignment definition links an active structure element, for example, a role, an application component, or device, to a behavior element, process, function, interaction it performs. Assignment example: a customer service representative role is assigned to a handle complaints process, or an application component is assigned to a data processing function. Key considerations for assignment: explicitly models who or what is responsible for performing a behavior. Access definition depicts how a behavior or active structure element creates, reads, writes, or deletes a passive structure element, for example, data object. Access example: a process reads, writes a customer data object, or an application component has read access to a database. Access key considerations: the direction and nature of access, read, write, can be shown with special notation or a note in the model. Behavioral relationships capture the flow and dependency between activities. Triggering shows how one behavior starts or causes another, while flow represents the transfer of data or resources between elements. Triggering definition shows a sequence or dependency between behaviors. One behavior starts or causes the next. Triggering example: completing validate customer information triggers approve loan. Key considerations for triggering: often used in process flows or event-driven chaining of activities. Flow definition represents the transfer of information, resources, or materials between elements. Flow example: information flows from a sales application to an inventory management application. Key considerations for flow: flow typically represents data or resource exchange, whereas triggering represents a temporal or causal sequence. Dependency relationships show how elements rely on or support each other. Serving indicates that one element provides functionality to another, while realization models how a concrete element implements an abstract concept. Serving definition indicates that one element serves or provides functionality to another. Serving example: an application component serves an application service, or a business service is served by a business process. Key considerations for serving: commonly used to model service-oriented dependencies, or the direction typically goes from the provider to the consumer. the serving element to the served element. Realization definition. This shows that a more abstract element is realized, implemented by a more concrete element. Realization, example, a business service is realized by combining application services and business processes. Or a logical application component is realized by a physical application component. Realization I considerations, often used across layers, such as business to application or application to technology, indicating how an abstract concept gets implemented in practice. Motivational relationships describe how strategic elements like goals, drivers, and requirements influence architecture. Influence captures the directional impact. Association provides generic links, and specialization shows hierarchical classification. Influence definition shows how an element, for example, a driver, goal, or principle, influences another in terms of impact, positive, negative, or neutral. Influence example, a compliance requirement influences a business strategy, requiring changes. A cost reduction goal influences a technology architecture principle. Influence key considerations, used to show strategic or motivational causality. Not always a strict dependency, but rather a directional effect. Association, motivational generic definition, a generic relationship linking two elements without implying a strong semantic. The motivational layer can also show commentary or annotations. Association example, a stakeholder is associated with a requirement. Association key considerations, used when no defined relationship type captures the desired semantics. Specialization definition, indicates inheritance or classification. One element is a specialized version of another. Specialization, example, a manager role is a specialization of a more generic employee role. A mobile banking app component is a specialization of a more generic banking app component. Key considerations for specialization relationship, useful in modeling taxonomies or hierarchical classification in the strategy or business layers. To create effective models, use consistent relationships, align them with the semantics of the layer, and avoid overusing generic relationships like association. Always check the directionality of relationships to ensure an accurate representation of dependencies and flows. Keep it consistent. Use the same relationship type across similar contexts. If describing part whole, consistently use composition or aggregation as required. Leverage layer semantics. Archimate layers, business, application, technology, and strategy motivation have nuances. The relationship type might differ if you model business processes rather than technology components. Avoid overusing association. Because association is generic, using it too often can water down your model's clarity. Prefer specialized relationships whenever possible. Check directionality. For serving, realization, triggering, flow, etc. Be mindful of the arrow direction to indicate who provides versus who consumes or what triggers what. Document your intent. If the semantics might confuse readers, add a note or rationale in your repository tool to ensure stakeholders understand why a particular relationship type was used. When to use one relationship over another. Composition versus aggregation. Use composition for strong part-whole relationships. The parts can't meaningfully exist apart from the whole. Use aggregation for looser groupings. The parts can exist independently. Triggering versus flow. Use triggering to show a temporal or causal start of one behavior by another. Use flow to show the movement of information or materials, for example, data flows, communication lines. Assignment versus serving. Use assignment when linking a role application component to the exact process or function they perform. Use serving when an element provides a service that another element consumes, for example, an application service used by a business process. Realization versus influence. Use realization to indicate how a system or process concretely implements an abstract concept, for example, a service. Use influence in motivational strategy modeling to reflect how high-level drivers or goals shape or constrain other elements. Association. Use when no other relationship captures the meaning, or you need a simple, generic connection without implying a strong semantic. In summary, Archimate relationships are vital for capturing interactions across layers in an enterprise architecture. By selecting the correct type, be it composition, trigger, serving, or influence, you can create clear, actionable models that align with strategic goals and operational realities. Modeling a customer onboarding process, business layer. Composition. Customer onboarding process is composed of collect customer data and verify identity sub-processes. Triggering. Verify identity triggers open customer account. Serving. The customer onboarding process serves as a customer onboarding service available to external customers. In summary, Archimate relationships are vital for capturing interactions across layers in an enterprise architecture. By selecting the correct type, be it composition, trigger, serving, or influence, you can create clear, actionable models that align with strategic goals and operational realities. Aligning business services to application services, application layer. Assignment. A CRM application, component, is assigned to handle the Manage Leads application function. Realization. The Manage Leads business service is realized by the lead management application function, which is hosted on the CRM application. In summary, Archimate relationships are vital for capturing interactions across layers in an enterprise architecture. By selecting the correct type, be it composition, trigger, serving, or influence, you can create clear, actionable models that align with strategic goals and operational realities. Strategic goal and motivation strategy layer. Influence, the expand market share goal influences the develop new products requirement. Association, a stakeholder, VP of marketing, is associated with the expand market share goal, indicating sponsorship or interest. Archimate defines specific relationships to model the structure and dynamics of enterprise architecture. Real-world descriptions often use varied terminology that doesn't directly match Archimate definitions. The challenge lies in interpreting and translating these terms into the appropriate relationships to maintain model accuracy and relevance. Why are translations needed? Enterprise stakeholders often describe interactions, dependencies, or structures using domain-specific language. Architects need to data mine language for synonyms that align with Archimate relationships. Accurate translation ensures consistency, communication, and alignment across models. AI-based analysis tools or synonym mapping functions from a word processor may be leveraged to correlate terminology with Archimate relationship types. This approach enables automated or assisted identification of relevant relationships based on contextual meaning, facilitating consistent modeling and alignment with standardized relationship definitions. The following slides will provide examples of what you may find when interacting with your stakeholders. The composition represents a fundamental structural connection in which an element is formed by one or more integral parts whose very existence depends on the whole. This relationship is beneficial for modeling scenarios where each constituent is an inseparable piece of a more significant entity, highlighting a high degree of interdependence. For example, formation illustrates creating something by combining parts or elements, demonstrating how discrete pieces form a unified whole. Similarly, makeup emphasizes the constitution of a system, how various components merge seamlessly into its overall structure. Another example is structure, which refers to the arrangement and interrelations of parts within something complex, underscoring how each segment supports and depends on the larger framework. Assembly involves gathering and uniting parts to produce a cohesive result, illustrating a dynamic approach to building composites. In the same vein, configuration focuses on positioning elements in a specific form or pattern, highlighting the deliberate organization of the system. Construction further underscores assembling multiple components into a single unified product. Finally, arrangement centers on methodically placing items in a particular order or layout to fulfill a specific design or purpose. These examples show how composition provides a structured method for representing interdependent relationships, ensuring that each part is recognized as an essential piece of a comprehensive whole. The specialization relationship represents a key structural connection in which a more specific element derives its characteristics from a more general one, creating a hierarchical framework. This relationship is vital for illustrating how particular capabilities, skills, or domains evolve into focused and refined areas of expertise. For example, expertise represents advanced knowledge or skills in a specific location, showcasing the depth of specialization. Similarly, niche highlights a distinct segment within a larger market or domain, emphasizing a particular focus. Finally, specialty narrows the scope further by pinpointing a specific area of proficiency within a broader field. These examples demonstrate how specialization fosters a clear and structured approach to defining and organizing complex systems and capabilities. The aggregation relationship represents a structural connection in which an element is formed as a collection of other elements while allowing the aggregated parts to maintain their independence. This relationship is essential for illustrating how individual components can unite to create a unified whole without losing autonomy. For instance, collection describes bringing together items into a group or set, highlighting the foundational aspect of aggregation. Similarly, accretion refers to gradually accumulating additional layers or matter over time, showcasing a dynamic process of building aggregates. Another example is cluster, which represents a group of similar elements positioned closely together, emphasizing spatial or conceptual proximity. These examples collectively demonstrate how aggregation can help model relationships where independence and unity coexist in a structured way. The influence relationship represents a dependency connection where one element affects, constrains, or guides another. It highlights the causal or guiding forces that shape a system's behaviors, outcomes, or decisions. For example, impact underscores one element's strong effect on a situation, demonstrating the tangible outcomes of influence. Similarly, authority emphasizes the power or right to guide and enforce actions, reflecting structured influence within hierarchical systems. Another example, control, represents the directed power to influence behavior or events, showcasing deliberate and focused influence. These examples collectively illustrate influence's diverse ways, from subtle guidance to explicit power, making it a critical relationship in understanding dependencies and strategic alignments. The association relationship represents a versatile connection between elements, linking them in a general sense without the specificity of other relationships. It emphasizes collaboration, cooperation, or a simple connection between components within a system. For instance, connection highlights the fundamental act of linking ideas, people, or entities, demonstrating the essential purpose of association. Similarly, partnership reflects a cooperative arrangement where parties collaborate to achieve mutual goals, showcasing the potential depth of an association. Another example, affiliation, captures the state of being closely linked to an organization or group, illustrating formal or informal associations. These examples collectively show how association relationships represent diverse connections and collaborations within a model. The realization relationship represents a structural connection where one element fulfills, implements, or brings another aspect to life. It is particularly valuable in illustrating how abstract concepts, such as strategies or goals, are translated into tangible outcomes or operational components. For example, achievement highlights the effort and success in realizing specific objectives, demonstrating the active realization process. Similarly, fulfillment represents completing a desired goal or outcome, marking the transition from intention to actuality. Another example, accomplishment, reflects the successful realization of a task or goal, emphasizing the concrete results of this relationship. These examples illustrate how realization bridges the gap between the abstract and the concrete, making it a vital relationship for understanding the execution of ideas and objectives. The serving relationship represents a dependency where one element provides functionality, resources, or support to enable another element to operate effectively. This relationship is key to illustrating how components within a system collaborate to achieve goals. For example, assisting highlights the act of helping or supporting to enable success, showcasing the collaborative nature of serving. Similarly, providing reflects the act of making resources or functionality available, underscoring the dependency of one element on the other. Another example, delivering, demonstrates the act of handing over what is required, ensuring the recipient can fulfill its purpose. These examples collectively show how serving relationships emphasize the interconnectedness and mutual support between system elements, ensuring overall efficiency and functionality. The triggering relationship represents a dynamic connection where one element initiates a process, event, or interaction in another. It is essential for modeling sequences and dependencies that rely on temporal or causal connections. For example, initiating captures starting or beginning a process, showcasing how triggering sets events into motion. Similarly, activating emphasizes making something active or operative, illustrating the transition from potential to action. Another example, sparking, highlights the moment a reaction or series of actions is triggered, underscoring the dynamic nature of this relationship. These examples demonstrate how triggering relationships bring systems to life, defining the flow of activities and interactions in a structured manner. The flow relationship represents a dynamic connection that signifies the transfer of information, goods, or resources between elements. This relationship is essential for modeling the movement of data or deliverables within a system, ensuring continuity and interaction. For instance, stream highlights a continuous flow in a particular direction, symbolizing the steady transfer of resources. Similarly, surge represents a sudden and powerful movement, showcasing the intensity or urgency within a flow. Another example, progression, captures the gradual movement toward a more advanced state, reflecting the evolving nature of flows. These examples collectively illustrate how the flow relationship brings systems to life by modeling the exchange and movement of key elements. The assignment relationship establishes a structural connection between a behavior and an active structure element, defining responsibility for performing specific actions or processes. This relationship is crucial for modeling accountability and clarifying who or what is responsible for executing particular tasks. For example, task represents work delegated to someone, highlighting the practical application of assignments. Similarly, responsibility underscores the obligation to manage or deal with something, emphasizing accountability in the relationship. Another example, role, illustrates the function or part played by an entity in a given situation, showcasing how assignments align with predefined duties. These examples demonstrate how the assignment relationship ensures clarity and responsibility and execution within a system. The access relationship represents a structural connection that defines how a behavior or active structure element interacts with a data object, whether by reading, writing, or both. This relationship is essential for modeling permissions, interactions, and control over information within a system. For example, entry highlights gaining access to a system or space, emphasizing the initial point of interaction. Similarly, gateway represents a means or point of entry, symbolizing controlled access pathways. Another example, availability, underscores the state of being able to use or obtain something, reflecting the broader implications of access in ensuring functionality. These examples illustrate how the access relationship captures the essential interactions that enable systems to function effectively and securely. Archimate relationships are crucial for describing how architectural elements interact across different layers. By choosing the correct relationship type, whether composition for a strong part-whole structure, trigger for event sequences, serve for service provisioning, or influence for strategic alignment, you create more precise, actionable enterprise architecture models. Always consider the meaning, direction, and layer context when selecting a relationship, and document the rationale to keep your architecture transparent and maintainable. Thank you for joining me on this journey through enterprise architecture and Archimate. If you enjoyed this presentation, please give it a like. Think of it as your way of hitting the lever in Skinner's box. Like in the famous experiment, every like is my reward and encouragement to keep delivering content that informs and inspires. And of course, feel free to share your thoughts or questions in the comments. Your feedback helps shape what comes next. Until next time, keep exploring, keep learning, and stay curious.